Hey everyone, welcome to the MacMillan Space Center. I'm Michael, the Program Coordinator here at the Space Center located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh Nation. Thank you so much for joining us to our now bi-weekly segments where we're going to get to talk to our astronomer, Rachel. How's it going, Rachel?
Going well, thanks.
So we got a lot to get to this week, Rachel, because we've had a lot of things happening. We've had a couple cosmic nights. So let's go over what we're going to talk about. We're going to talk about lakes on Mars, like what? Big news of the week. We'll do a recap of cosmic nights, exoplanets, which happened a few weeks ago, and we're going to preview the next cosmic nights, which is going to be about dark matter. But Rachel, before we get to that, I have to ask you and everyone out there on YouTube land, did you see the moon last night?
I didn't, but you were saying that there was something cool that happened.
Yeah, so I walked out outside last night and I looked up at the moon and I kind of panicked because I was like, wait, did we just miss a lunar eclipse? Like, did we just have like a lunar event that we were supposed to plan for? Because the moon was this red color, which is exactly what a lunar eclipse looks like. I've seen a lunar eclipse several times and I was very confused. And then I realized, oh, the smoke is in the air and it's creating this effect. The sun is also being very reddish as well. So, Rachel, can you explain what's going on here? Did we get a free lunar eclipse last night?
Sure. So a lunar eclipse happens when the moon moves into the Earth's shadow, but that's not what happened yesterday, what you saw yesterday. And I've been getting a lot of questions from kids wondering, why is the sun all of a sudden a different color? Why is the moon a different color? Why is it not white and what we expect when it reflects the sun's light? And the reason being because of all the smoke particles in the air. And so I kind of explain it as like, it's almost like a little bit of an optical illusion, kind of like when you see the moon getting really, really big when it's really close to the horizon. But it's just having to do with all the things in the air. So when the light comes from the sun, it passes through our atmosphere. There's more things in the atmosphere, more particles, and so it looks a little bit more hazy, a little more red.
Oh, interesting. Yeah, no, it looked amazing. Perhaps today will be a little bit cloudy as well, and it is pretty much a full moon. So if the clouds are parted, go check out the moon. All right. So, Rachel, speaking of reddish planet like things up there in space, not the moon, but an actual planet that is red for different reasons. Mars was in the news this week because, last time we were here chatting about potential of life on Venus, and I guess Mars got a little jealous because they were like, wait a minute, we've got a lot of water here. And there was a new discovery, a new paper that was published about lakes on Mars. So you've got a little presentation for us. So
We
why don't we
do.
get to that? And then anyone out there on YouTube, we're going to take lots of questions on lakes on Mars. And of course, anything else you want to talk about.
So this is really cool. It's a really great month for the search for extraterrestrial life, I suppose, with Venus and phosphine and Mars with buried lakes. So here we have the 2018 detection of a large body of water. But the reason why it wasn't a big deal back then is because they weren't totally sure about it. They wanted more data. They only had 29 observations. And so over the course of a few years, they ended up getting over 134 observations over 7 years, so much more than 29. So they're a little bit more sure that there are subglacial lakes here on Mars. So here is some data from the paper that was published. Here on the top right, you'll see I've outlined the locations of the subglacial lakes. So the big one that you see in the center, that is the proposed detection from 2 years ago, and the one that they have followed up with the new detections now. And then the three smaller ones around are the newly proposed detections of the three subglacial lakes by a research team. And how they did it is they used a science instrument called MARSIS. And how MARSIS works is it uses something called radar echo sounding. And if you take a look at the bottom here, so what happens is MARSIS sends out a radio pulse, and then it takes a look at how that signal is reflected back. And we have difference in the brightness of the signal when it gets reflected, depending on the type of material. So if MARSIS were to detect something that was going through an ice and then a water boundary, they would see a much brighter signal. So that's what they were looking for. They were looking for bright signals that would tell them that the pulse was traveling through ice, then water, then being reflected back. And that's exactly what they saw. And so MARSIS was sent on board the Mars Express, and oh, here we go. And it began to collect data in 2005. And so it's really interesting because the lake that they found, or they're proposing that they found in the middle, is very, very big. It's 20 kilometers by 30 kilometers. So it's kind of interesting that we found, or have believed to found, a massive lake underground. And something that's interesting is that, so with these subglacial lakes, we do have subglacial lakes here on Earth. And if you take a look on the right-hand side, I've shown a picture of Lake Vostok, which is in Antarctica, and that's hidden below a few kilometers of ice, just like we're proposing we see at the Martian South Pole with this new body of water. But then researchers knew that the temperatures around the South Pole are below freezing. So in theory, we shouldn't be able to see liquid water in its liquid form at the South Pole. So what they're proposing is, if it is truly a body of water, then maybe it is extremely salty, or what they call hypersaline. So they're thinking that super salty lakes can exist in liquid form below freezing temperatures. And it just so happens that if you take a look on the right hand or the left hand side here, this is called a phase diagram. So it tells us the necessary pressures and the necessary temperatures for water to exist in liquid form. And that's the blue region that I've highlighted here. And so we see that Mars doesn't have the necessary temperatures and pressures because it doesn't have a substantial atmosphere. And so it's kind of interesting that we found these hypersaline lakes underneath Mars. I'm just going to skip ahead here. And so there is a lot of controversy surrounding whether or not there is liquid water on Mars. There are skeptics wondering about the interpretation of the data that they've collected. And so they're not opposed with the actual data itself, but they're opposed to the interpretation of it, because what the researchers have done is they've collected data, they've collected even more now, in addition to the 2018 data, and they've applied what we apply to terrestrial polar ice sheets to the ice sheets on Mars. So we're using the same techniques that we do on Earth on Martian polar ice caps. So that was kind of a little bit of a debate whether or not that is applicable, the analysis that we use on Earth. But as humans, we only know that life for sure exists here on Earth. So we're using Earth-based techniques to try and figure out if there is subglacial lakes elsewhere in our solar system. Alrighty.
Yeah, so everyone out there, if you have any questions about water on Mars or on lakes on Mars, put them into the YouTube chat. Rachel, so we had a bunch of 2 launches back in July going towards Mars, and this coming February, we're going to be hopefully seeing the arrival of those spacecraft. Now, so far, the majority of the spacecraft that have gone to Mars, that have landed on Mars, have been sort of like around the equatorial belt, right? So this region that you're talking about in the South Pole, that's largely been unexplored by all of the rovers that we've sent there, right?
Exactly. Yeah, the data that we're seeing from things like the Mars Express are orbiting satellites.
And so is there anything planned so far? Like the 2, so Perseverance, the NASA rover, and the Chinese that's heading there as well. Are either of those going to be exploring the southern pole region?
Right. So the Tianwen-1 mission, which is hopefully landing there in February of next year, they have a rover, and they're hoping that they can deploy that rover and maybe settle this heated debate between the skeptics and the optimists. And they're hoping that they can actually go and get a sample and see and analyze a physical sample. So not using these radar sounding techniques, but able to analyze the material itself.
Oh, wow. So it actually is going to go towards the South Polar region.
That's what they're hoping.
Oh my God, this is so amazing. Well, this is also interesting because the other news that had kind of like snuck in the past couple of weeks was the NASA announced that when it goes back to the moon, it also wants to explore sort of like the South Pole region down there, because years and years prior, the L-Cross mission found that there was some ice down deep inside a crater. So are these South Pole regions, like around the moon and the Mars, are these like really high percentage chances of maybe finding this water and maybe even life?
Maybe, but like the deal with finding ice or water or in whatever form in these craters is because it has kind of these shadows that are in these craters. So that means that not enough light and not enough heat can irradiate or shine on those spots to melt ice and not let water form there. And so in these polar ice caps, we're hoping that maybe because the Martian surface is totally not suitable for liquid water at all, it doesn't have an atmosphere, it's just terrible for liquid water to survive, it's very dusty. So we're hoping that any water that could have been there is just buried very, very deep underground.
And what kind of ice do we know what kind of ice it is? Because this notion that we're comparing Earth-based knowledge to these places. So when we talk about ice, is it the same kind of ice, or do we not know yet until we actually take a sample of it?
So it's a mixture. So it's a mixture of the ice that we regularly know, which we call water ice, and also carbon dioxide ice, which you probably know more commonly as dry ice.
Oh yeah, I definitely know dry ice. We've had some events here where we use some of that dry ice, but that's really neat. So there's carbon dioxide ice. So I'm trying to picture sort of like what the rover would see, would it be sort of like that sort of almost like it would be whitish, it would be reflecting some light, but maybe a little bit more hazy, sort of like how dry ice is.
Yeah, and like I'm imagining something that looks a little bit like Lake Vostok in that picture that I showed you with the kilometers worth of ice hidden above or stacked on top of this hidden subglacial lake. So it's something similar, with the rover being at kind of like Antarctica and on top where the science stations would be, and hopefully just drilling straight down.
Amazing. So that's where sort of the Tiananmen is going. And then in February, we're probably going to be doing lots of stuff around Mars. And then we're also talking about Perseverance. So is Perseverance sort of like on another mission on another part of Mars? It's amazing to think that there's going to be all these robots all around Mars. No humans, just robots on Mars. What's Perseverance going to be up to?
Yeah, it's funny to think that Mars is purely populated by robots right now. But Perseverance is looking for the geological history of Mars. And
Okay.
the purpose Perseverance is going to do is it's also going to be sampling things. But it has a nice little drill that can drill down and collect samples. And actually, it's hoping to collect samples for storage that maybe we can go back later and go pick up the physical samples and bring them back to Mars, which we haven't done yet because it's very expensive to send things to Mars, let alone bring things back from Mars.
Right. And of course, we did get into a lot of this back in July with Geraldo Moranci from the University of Chicago for our Cosmic Nights, which we had a deep dive into Mars. We'll most likely do another deep dive in February. Mars seems to always wants to be in the spotlight. We really need to give Venus some more love as well. And speaking of Cosmic Nights, a few weeks ago, we got into exoplanets, which, of course, speaking of trying to compare our planet to other planets, we're now have to like forget about our own solar system and thinking about brand new planets that have all sorts of different shapes and sizes. And we spoke with Dr. Michelle Kunimoto, who is now at MIT, used to be at UBC, your former alma mater, and she shared with us some amazing stuff. And what was sort of like the highlights for you from that Cosmic Night?
You know, the thing that stuck out to me the most was the fact that she was really emphasizing the fact that citizen science projects exist, which means that I can sit in my sweatpants in my bedroom at home, sipping coffee, and contribute to science. And so at MIT, Michelle was working on the TESS mission. That's the Transiting Exoplanet Survey Satellite. And so she showed us that you could go onto a website called Zooniverse, and that is a platform that hosts a whole variety of citizen science projects, but particularly in the space segment, they have a project where you can contribute to the TESS mission. So you're actually analyzing data from TESS, kind of like Michelle is, but she's doing it at a whole other level. But you can do it from the comfort of your own home. And I thought that that was a really cool message.
I'm now like picturing one of the questions I want to ask everyone is, what would you be wearing if you wanted to discover an exoplanet? It's sort of like this fun thing where now we can do all this amazing work without actually putting on work clothes. Myself, I'd probably be wearing my bow tie. You know, that's if I'm going to do some space stuff, I still got to keep the uniform on. But everyone in the chat, what would you be wearing if you could use some of the citizen science software? Do you have like a favorite shirt that you'd want to be wearing if you discovered a brand new exoplanet? Let us know in the chat. But we do have a question back on our Mars subject from Harry, who asks, what life would Earth Mars have in super salty sub lakes? So, you know, what I guess sort of like speculating what we might find maybe in Lake Vostok or maybe down in these lakes on Mars.
Sure. So it would absolutely be some sort of extremophile. And there is a chance that it could be some form of anaerobic life. So you and me were aerobic life forms because we require oxygen. We need oxygen for metabolic processes and just to survive in general. But these anaerobic life forms don't need oxygen. So they can survive in places like super salty lakes or even just in like places where there isn't a lot of air, there's not a lot of oxygen, it doesn't need oxygen to survive. So if I was going to speculate as to what these aliens would look like, it probably wouldn't look like little green men, but probably more like microbes and maybe amoebas that are floating about, kind of like bacteria.
Yeah, that's really interesting, and that's actually a workshop that we do here with kids. Last Saturday, I don't know if anyone joined us in person. We do a workshop all around extremophiles and looking at the different environments, and anaerobes were certainly one of them. It's hard to wrap your brain around, some of that, but we get to have fun. We use plasticine, so we're going to do more of those workshops here in person. But yesterday, we also did one for some home learners as well, and I'm not sure if we have any home learners joining us here today, but we'll be doing more specific sessions just for home learners. We're going to be doing one for a younger age group for grade ones. So check our website for those details. Extremophile is always a fun topic. Let's get to another question here from B. Edwards. Would they get samples of the Mars ice? And if so, would they be able to tell if there was some kind of life in it?
That's a good question. So I'm thinking that they are looking for direct samples to try and settle this debate on long range detection. So using an indirect form of detection like that radar sounding. And so if they were to take a sample, they're going to want to look for things like biosignatures or organic molecules that are present there. And my hope is that they do find something because, I feel like we're ramping up towards it. First with Venus and phosphine gas, and now with Mars and the subglacial lakes. I feel like the next thing is finding life on another planet, hopefully.
Yeah, it does sort of feel like every one of these discoveries that we're getting just a little bit closer to that answer, and more people now start looking, and it is sort of like almost like a mob mentality of scientists, of kind of like everyone's kind of like feeling, okay, we're getting close here, we're getting close. And of course, everyone wants to be that first discoverer. You want to be on the team to make that discovery because we're talking about something that will just completely change, our perception of the universe. I mean, we're already talking about it, but making that discovery would then launch us into a whole new, different faction of science.
Yeah, that'd be really cool to go from a sample size of 1 to a sample size of 2 for life in the universe.
Yeah, so if you're think about that for a little bit, just to ponder that question, maybe the atmosphere of Venus, maybe in these subglacial lakes of Mars, where else do you think that we might find it in our solar system?
I think maybe Europa, because Europa kind of has a similar thing going on to Lake Vostok and that subglacial lake that could be on Mars. So it's covered in this really, really thick ice sheet. Again, it's kilometers wide, but it's speculated that maybe the underwater ocean that's underneath this ice sheet could contain more water than all the water in the oceans on Earth combined. And so it would be a perfect place for life forms to thrive because Europa does have those 3 key ingredients for life. It has an energy source. It has this place where you can get liquid water, get oxygen for any sort of life forms to exist. So if I was going to guess somewhere else, it would probably be Europa.
Interesting. And Pride jumps in with a comment about life being microscopic, which likely this phosphine life would be probably microscopic, as well as the life in Mars's subglacial lakes. But do you think that this would be intelligent life? What do you think, Rachel? Are we talking about just like bacteria? I mean, do we classify bacteria as intelligence?
Yeah, so that's an interesting question. What is the threshold for something that is intelligent or not? Because I would say that my neighbor's dog is pretty intelligent. She knows where all the food is stashed. She knows how to open the compost bin. But if we're speaking in terms of microbial life, then I think that that is well below the threshold for intelligent life forms. And we're looking for something that's like what the Drake equation proposes or what the Fermi paradox is talking about. And that's intelligent civilizations that can establish contact and are similar to us in that they are spacefaring and space exploring nations or civilizations.
Yeah, but certainly I think most scientists, have a great reverence, for all forms of life, especially looking for it out there in the universe, because of course at one point we were a very primitive form of life as well. And it just took time for us to evolve, a lot of time, but we eventually got here, right?
But that'd be cool to see, like, if we did find kind of what we were like in the early stages of life, to on somewhere else, it would be like looking into our past and seeing the beginning stages of life on a totally different planet. And I think that that would be just mind blowing to see.
Yeah, I remember there was an episode of Star Trek where I think Q took Picard back to like the very beginnings of time, and there was like just like this little puddle of goo, and he was like, "Oh, there you are, humanity making its first connection," and it was just like this like little mush pile. I thought
Pretty
that was really
lackluster.
funny. But that's kind of a very good analogy for what we may be finding here, right? Like
Yeah.
eventually when we go down to these places, it's just going to be like it may not be like a ugly pile of glue, but it could be a very dry ice area of goo.
Yep. I'm imagining just something that looks like bacteria just floating around.
All right, Rachel. So we've got about 5 or 6 more minutes. Of course, if anyone has any questions about any of the stuff we've talked about, water on Mars, lakes on Mars, we talked a little bit about exoplanets. But in a couple of weeks, on October 15th, we are going to be doing another Cosmic Night. And we have found a special guest, Dr. Ten Tian Yu from the University of Oregon. We're going to be getting into a very, very dark mystery, and that's talking about dark matter. Super excited about this next Cosmic Night. Rachel, in a couple sentences, of course, it's hard to describe very quickly, but what is dark matter?
And that's a complicated question, because we know more about what it isn't than what it is. But in short, it's the substance that allows for galaxies and galactic clusters to exist. It interacts through gravity, and without dark matter being present, we probably wouldn't even be here because planets couldn't form, things couldn't clump because of gravity. And so dark matter is this unknown substance. It doesn't interact through electromagnetic radiation, which is kind of a bummer for us because we detect things using light and using EM radiation. And so we're hoping to see if we can figure out what a dark matter particle looks like.
Amazing. Yeah. And that's true. So we're actually going to be sending out a little art activity as well for you to interpret perhaps what dark matter might be. Because as you say, Rachel, sometimes we just have to rule out what it's not first before we can figure out what it is. So we're going to have some fun. That's October 15th. Make sure to get your tickets. They're going to have exclusive interviews. You're going to get a chance to ask Dr. Yu some questions, as well as Rachel. We're going to be there as well, talking about the other stuff that is in the universe. And then we are going to be doing a live session around the OSIRIS-REx mission. So the next week after that, we don't know what time it's going to happen yet. I don't think they've announced it yet, but the OSIRIS-REx mission has been orbiting around an asteroid Bennu, and it's actually going to land on the asteroid very briefly, take a sample, and then start to head back to Earth. So we're going to do a live session around that. Super excited about that. And then, of course, we're going to be doing more in-person sessions. So unfortunately, if you don't have a ticket yet for this Saturday, we're going to be outside in the Natural Planetarium. We're going to be looking up at the nighttime sky, opening up our observatory. Not to worry, we're going to be doing more of these sessions coming up. You know what to do. You like and subscribe so you get the notifications for all of our live streams. Go onto our website and you can see all of the events that we have coming up. Haven't quite opened up everything yet, but we're slowly getting there, and we really appreciate all your support. You can let us know through the surveys, the kinds of things that you do like, and also the subject matters that you may want to get into, because we're brainstorming all of this fun stuff here. And it's really fun for us. But yeah, let us know because we really appreciate your support. All right, Rachel, is there anything else that I'm missing here?
No, but I'm excited for everything that's coming up. 2020, the end is really ramping up.
Yeah, I mean, it's been a very bizarre year, hasn't it? Like
Yeah.
we've been doing a lot more of this. We're building up our YouTube channel. So really appreciate everyone that joins in to these live chats, liking and subscribing, and telling some friends about our programming, especially if you are a homeschool. If you're a kid watching right now, you're homeschooled. This is a great chance every 2 weeks here, Thursday, 2 o'clock. But also, we have specific specific sessions that are connected to the curriculum. So if you go onto our website and you'll see, we've got grade 1, we've got grade 4, grade 6, grade 7, even grade 9, a bunch of different things that we're offering, as well as some of the in-person shows and workshops and observatory nights that we're going to be doing. And hopefully this will keep us going till 2021. Rachel, so great to see you again. Thanks to everyone out there in YouTube land. We will see you in 2 weeks. Bye, everyone.